Hey everyone, this is Mr. Bells here. This is a GOB video going out after our quadrilaterals test. And it's pretty much, I think it might help anybody, but I feel like there's several students that are struggling on some of the concepts that I think could maybe be a little bit easier for them than maybe what's currently happening. And I'm going to try and clear some stuff up. Again, hoping this will just help for any of you that are struggling with what they're looking for and what to do when on different types of problems. So here is so the first thing that I want to talk about is just solving a basic equation. So 3x plus 18 equals, let's call this 40. So if I have something like this, then you know, get that away from the microphone a little bit more so you don't hear any of that hum, or at least hear less of it. 3x plus 18 equals 40. So when I do this and I'm trying to solve for x, I'm going to do the opposite. Anytime that you move something across an equal sign, you have to do the opposite. And since this is plus, we would do minus. So then I'd get 3x is equal to 22. And then 3 is multiplying the x, so I'm going to do division. And that's the opposite of it. So x is equal to 22 thirds. Now, the same thing is true as if you have stuff on both sides. So if I do 4x plus 6 equals 7x minus, let's go 10, and I'm trying to solve this equation, I'm going to go ahead and try and get my x's together first, because just like over here there was only one x, I want to get my x's together. So I'm going to move this 4x, and I can move the whole thing to the other side. And again, because I'm moving it across the equal sign, I need to do its opposite. So then I'd have 6 equals 3x minus 10, and then move the 10 plus 10 plus 10, I get 3x is equal to 16. And then I divide by 3, and I divide by 3, and I get x is equal to 16 thirds. And you can, feel free to leave it like this, or change it to 7 1/3 or 7.3 repeating, or over here, this would be 5 1/3, or 5.3 repeating, whatever it is. But one of the things that would help is, once you do this, if you take that answer and you plug it back in to the original equation, it should be true. So like if on my calculator I did this, clear, I'll go to my home screen, and I do 3 parentheses 7.333333, I just do a bunch of them, parentheses plus 18, when I hit enter on this, it should say it's 40, and it does. So that means I know that I solved that right. Over here, I can do it this way. So 4 parentheses 5.33333333, enter, plus 6. That's 27 1/3, and it's supposed to equal the same thing on this side. So I do 7 parentheses 5.33333333, parentheses minus 10. You can see they're both the same things. So I know that I've done it correctly. Another thing that you can do if you have this calculator is, once you have, say your final answer was 22 thirds like this, and you got that as your answer, you could just hit the store button right down here, store that answer in x right here, and hit enter. And then you could just type 3x plus 18 over here. So I got 3x plus 18. And you can see that it's 40 that way. Whichever way you want to do it's fine with me. Okay? So that's one of the first things. How do you check answers to make sure that you did them right? Now the next thing I'm going to deal with is shapes. And I feel like shapes have really given some people some trouble. So before I even do that, I'm going to talk about 2 points. Awesome. So if I connect 2 points right here from A to B, this is called a segment. And a segment has a distance. It's how far it is, how long it is, and we could measure that. Like on this one, on this piece of paper, it's about 2 inches, and that's the symbol for inches. It's not 2 to the 11th power, so 2 inches long, approximately. Okay? Again, that's on my paper. If you're watching this on your phone, it's going to look a lot smaller, but again, about 2 inches. Now this, if I have 3 points, I can have something that's called an angle. And an angle isn't measured in inches at all. It's not measured in centimeters. It's not measured in feet. It's measured in, for us, something called degrees. And degrees measures how far open something is. Whereas this one right here is open about 40 degrees. And if I had this right here, this is open about 8 degrees. And the more I rotate up, the more I'd get. Maybe this one's open about 30 degrees. And if I keep rotating up on this, and I go straight up and down, this opening right here is 90 degrees. If I keep rotating it here so that my ray looks like this and like this, I have this big angle. This angle is over 90 degrees, and it might be somewhere around 160 degrees until it becomes perfectly flat. And this would be 180 degrees. And if we kept rotating it all the way around, from here to here, rotated all the way around, and started here and got back to here, that would be a rotation of 360 degrees, even if this angle right in here only shows about 60. Okay? So the reason why I put this stuff up is because on the last couple tests, I'm really getting some things that just don't make sense. So for instance, if I drew this picture out and I put this here, and I put say a 12 here and a 4 here, and I looked at this length right down here, these are all lengths, right? This, if I put an A, a B, and a C on this, segment AC is a length, segment AB is a length, and segment CB is a length. So I've had people that will put numbers down here for CB that are bigger than the number 12. And it just can't be, right? AB has to be the longest side. So again, this number has to be less than 12. And we can actually get that by using the Pythagorean theorem, but we're just talking about things that make sense. Now, does this 4 have any sort of measurement value for this angle theta? And the answer is no. This thing, right, measures an opening between 2 rays, and it's in degrees. This measures the length of a segment, and it's in millimeters or centimeters or whatever. And I feel like we're having a lot of things that are messing up. Let me give you an example of another thing that I saw on the test. So we had this, which I'm hoping that you guys know after the quadrilateral unit, that at least it looks like, even though it isn't, it looks like it's a parallelogram. And then if those two sides are equal and those two sides are equal, this guarantees that it was a parallelogram. Well, one of the things that I saw was if this was 3x plus 10 and this was 46, and I asked people to solve for x, I had some people that maybe weren't sure what was going on with this. And I know that there's angles in here, right? This right here is an angle, and this right here is an angle, and this right here is an angle, and this right here is an angle. And those refer to the openings that are between those two segments, okay? But I had students that unfortunately were getting stuff mixed up between segments and angles and would write stuff like this, that 3x plus 10 equals 360. Well, 3x plus 10 is great, that's an expression right there, but that expression refers to that length. And that length of that segment doesn't have anything to do with degrees, right? That's just not something that we want to write. That doesn't make any sense. But however, on a parallelogram, this side and this side are equal. So if those two sides are equal, that's what we can write. We can write 3x plus 10 equals 46. And then we could solve that the way we showed with the other problems, and we get 3x equals 36 because we subtracted 10 from both sides, and we get x equals 12. But I want to make sure we understand. This length right here is not 12. X, the value of x, is 12, which means we have to take that value and plug it right back up into there. And then you would see that 3 times 12 plus 10, 3 times 12 is 36 plus 10 is 46. You would see that those two things were equal. And that's what we'd be looking for. So I want to make sure there's a difference between segments or sides of shapes, which are measured again in distances, how long something is measured out, and angles, which are measured in degrees. And we've got to look at each one of these shapes and we got to know the difference. So if I had this picture right here, I have this shape. I have an A, a B, a C, and a D. And if I put this down, AD, this refers to a segment, 2 letters, segment, how long that thing is. And if this is 7 centimeters, where I just made that up, then I would write that AD is 7 centimeters. Now, if I also had these marks on here and these marks on here, then I should also be able to write that BC is also 7 centimeters because those two things are marked to be the same. Okay? But those distances have nothing to do with the amount of opening that there is here. That's a measurement in terms of degrees for something we call an angle. But there is something that's true about angles. Angle A plus angle B plus angle C plus angle D on any quadrilateral all add up to 360 degrees. So I know when somebody put 360 before, that's what they were thinking about. But this is a degree measurement. It doesn't have anything to do with the sides, the perimeter, or the area, or anything. It just measures all the angles. So the opening here, plus the opening here, plus the opening here, plus the opening here, adds up to 360. Now, on different quadrilaterals, there's different properties that exist. So for instance, on this one, this is called an isosceles trapezoid. And if those two sides are equal, like that, and these two sides are parallel, then we know that this angle right here, D, I'm going to put a little red dot, and this angle, C, put a little red dot. If those two sides are equal, then those two angles are equal. But that's just the case for this shape, isosceles trapezoid. So if I said this angle D, and I said that this was 78 degrees, then you would know that angle C is also 78 degrees. Okay? Not only that, I could write the 78 in up here, 78 in up here, and I know that these two angles right here, angle A, this opening, which is definitely bigger than 90 degrees, right? This was less than 90 degrees. This opening and this opening, because they're between parallel lines, have to add up to 180, so this one has to be 102 degrees. So angle A equals 102 degrees, and angle B then equals 102 degrees. Making the connections there. Now again, if I added 78 and 78 and 102 and 102 all up, it has to add up to 360 degrees. But because this had these markings, those two things also are supplementary. Whereas I had a lot of people that wrote if this was 78, they also wrote that that was 78. And I understand that there are two angles that are the same, but we shouldn't mark this one the same when this one's obviously bigger than 90 degrees and this one's less than 90 degrees. Does that hopefully make some sense? The next thing I want to talk about, I'm going to go with the same picture, new information. That I had an A, a B, a C, and a D here. And I know I put the letters in different order. It doesn't matter where it is. And I put that these two sides were congruent, and I put that these two things were parallel. And then we had this drawn in the picture. Good deal. And then there was statements that said AC equals 4x plus 2, and BD equals, well, let's say 6x minus 16. And then it says, well, how long is BD? Well, you'd have to look at this picture and you'd have to go, well, what is AC? Well, I had people assuming AC was an angle. Well, AC is not an angle, it's a segment. So we don't want to say anything with these being equal to 180. 180 refers to degrees. AC is this length right here. And I draw it, I just copy that down on my picture. I'd be like, that's AC. And then BD is this. I copy that down on my picture. And if those two things are those two things from my picture, I'd have to look at the picture and go, well, what do I know about those two things? Well, those two diagonals have to be the same length. So if they're the same length, I would take what they're equal to and write that. I'd write 4x plus 2 equals 6x minus 16, because the picture shows that those two things are the same length. So I write their expressions equal to each other. Now I'm going to go ahead and solve this. So then, of course, I do minus 4x and minus 4x. And a lot of you guys' algebra is really good. You're just doing the wrong stuff at the wrong times. And I think it's just because you're just not sure when to do which things. So I get 2 equals 2x minus 16 because I subtracted 4x from both sides. And then I'm going to move the 16 over here. So I do plus 16 and plus 16. And I get 2x equals 18. And then I divide by 2 and I divide by 2 and I get x equals 9. Right? But that's not how long BD is, right? That's what x is. And x is a value that goes in for these distances. So I have to take what x equals and plug it in. And it doesn't matter if I plug it into AC or BD because they're both the same length. And it should give me the same value. So 6 times 9 is 54. 54 minus 16. And it's okay. I don't have a problem if you need to go to your calculator and do 54 minus 16 and get that answer. At least we'll know that if you put it in right, it's going to give you the right answer. So that answer gives me 38. So let's just try it here again and plug it into this one. So 4 times 9 is 36, plus 2 is also 38. So both of them give me 38. And they should, because they are equal. Is that okay? Now, same picture again, different scenario. If I give you this picture, and I give you this and this, and this and this, and I say that this is 2x plus 12, and this up here is 4x minus 8, I have some students that are writing this. (2x plus 12 plus 4x minus 8 equals 360). Do those two angles add up to 360 degrees? Nope. I have some that write this. 2x plus 12 equals 4x minus 8. Now, it could be that on some of these shapes, those two angles are the same size, but I think on here it's pretty obvious that this angle right here is less than 90 degrees, and this angle up here is bigger than 90 degrees. So I can't have two things that are different sizes all of a sudden be written that's equal. So that doesn't make sense. I can't do that. However, these lines are parallel, which means these two things are supplementary, which means I can write 2x plus 12 and 4x minus 8. If I add those two things together, it does equal 180. And that's the relationship that's true on that particular shape. Now, I can go ahead and solve this. Let me go ahead and solve this. So I get 6x plus 4 equals 180. And some of you are thinking, well, why didn't I move this x over to this side? Well, you can see that those x's are on the same side of the equal sign, so I'm just combining them. I didn't need to move it across the equal sign. It's only when I move stuff across the equal sign, right, that I have to do the opposites. If they're on the same side, they could just hang out and party together, okay? So now I do minus 4, 6x equals 176, divide by 6, and x equals, and I go to my handy dandy calculator, so on 176 divided by 6, I get 29.3 repeating. So not the best number to work with, but it's what it is. Now, does that mean that angle A, this is angle B, that angle A equals 29.3 repeating degrees? No. Angle A is 2x's plus 2. 2 times whatever x is plus 12. Sorry, I said 2 a second ago. 2 times whatever x is plus 12. Well, x is 29.3, so I have to take this and shove it into there and do that math. So 2 times 29.3 plus 12, and I get 70.66. 70.66 degrees. Now, should I also get 70.66 for this? The answer is no, I shouldn't. This is a bigger angle. So I can't just assume that they're the same, right? That's when we wrote this statement. That doesn't make any sense. So I'm going to take my 29.3, and now I'm going to plug it into this one. And I have 4 times 29.3. And with this multiplication, it doesn't matter if it's in parentheses or isn't in parentheses. I'm going to do minus 8 afterwards. I'm going to hit enter, and I get 109.3 repeating. So I go here, and I write this one's 109.3 repeating. And it looks like it is, too. So it kind of helps it makes sense. Now, if I take that answer, 109.3, plus the other answer, 70.6, and hit enter, I should get 180 degrees, which is the relationship on that problem. Okay? So, I'm going to clear that out, and I'm going to show you a few things on the tests and see if this makes more sense now. Some of the problems that I got repeatedly marked wrong. Okay, so we define the word regular to be all angles and all sides congruent. All angles congruent and all sides congruent. And I had a bunch of people that marked this thing as regular. But you can see this angle is one angle, and that's about, I don't know, maybe about 10 degrees. But this angle right here is still one of the angles of the shape. It's connected by two sides. This angle right here is about 250 degrees. Are those two things the same? No. So we wouldn't call that regular. This one, the sum of the measures of the interior angles of a convex nonagon. Well, that's a lot of words, but sum means to add, interior angles, convex nonagon. So I got a 9-sided shape. So I'm going to add, this one's an 8-sided, and it's okay. We can use this 8-sided. I'm going to add an obtuse angle right here. So 1, 2, 3, 4, 5, 6, 7, 8 obtuse angles. So if it's a nonagon, that's actually 9 obtuse angles. And I had people whose answers here were less than 300 degrees, where we know that all 9 of those angles all had to be greater than 90 degrees, which means that this had to be at least 800 plus. Do we see what I'm trying to say there? So I know that there's a formula, and the formula is n minus 2 times 180. But I just want answers that make sense for the situation. Okay, so here we go. This one says, what is the measure of each exterior angle of a regular hexagon? So I'm going to draw a picture of a regular hexagon. Now granted, it's easier if I know what a hexagon is. But this is an exterior angle, and they want to know how big that angle is. Well, I got people that tell me that that angle right there, which is obviously less than 90 degrees, was like 720, which is just a different answer to this question. So I really want you to think about what it's saying that it is, okay? So, sorry about the bells. These ones down here, we gave a whole list of different stuff that you could say or couldn't say that was parallelograms, and I understand sometimes we just won't get those. These ones up here, these are not polygons. I had somebody that told me that this was a quadrilateral. Well, polygons by our definition were things with segments connected. And so they couldn't be curved and they couldn't be overlapped. So this is an overlap. This is not two triangles. It's not a hexagon. It's just not a polygon because there's overlap. The things cross. Okay, but let me go to some of the things that people had some real issues with. And let's see if we can talk about them a little bit differently and see if this makes sense. I'm going to go to this one right here. This one right here. So this is a rhombus, and this is the picture of the rhombus. And this 5x plus 15, it even has degree markings, is pointing to this angle right here. So we have this angle right here. So I'm going to ask you, how big is that angle? Well, even if we don't remember the properties of a rhombus, I'm hoping that we at least look at this and go, well, I think it could be 90 degrees because these things are perpendicular to each other, okay? So what would I write? I would write 5x plus 15 equals 90, because that's what's true about this. And this angle over here that 2x plus 3 is referring to, that's a really small angle. But I had a lot of people write 2x plus 3 equals 5x plus 15. And I'm pretty sure that that and that are not the same size. Like that's small. That's 90 degrees. That's less than 90 degrees. We can't write that. You know what I'm saying? That just doesn't make any sense. Now, once we do write this, and this is true, then we could solve for x, get what x is, and then plug x into this one to find out what that angle is. Okay? So that's one of the things that we're looking at. Just making sure that we set things up that are true or things that we can hope with. Okay? This one up here, this is a parallelogram. I had a lot of people on this parallelogram, that was 114, and they wrote this as 114. And I'm like, I don't understand, that's less than 90 degrees. And I know that there's another 114 one, but that other 114 one is right here. This can't be 114, that doesn't make any sense. Okay, so in the moment, and I know sometimes we get a little stressed out with some of this stuff, but in the moment we got to go, what makes sense there? I also had people write this, 2x plus 12 equals 114. Well, that's a side, and that's an angle, and those two things don't have anything to do with each other, right? So we don't want anything to do with that. We can't have, this is measured in inches, that's measured in degrees. That's like talking about that you weigh 27 years. You step on the scale and you weigh 27 years. Well, that doesn't make any sense. Weight is in pounds, age is in years. Those are the two things that are connected. Okay? Again, just hoping this stuff helps. Let's go down here to this one here. This is a rectangle. If this is 33 degrees, then this one has to be 33 degrees. Okay? And if that's 33 degrees and that's 33 degrees, then this angle right here, which is definitely not 90, has to be the difference between 180 and the two angles we've just used. So if I subtract 66, which is two sets of 33s, from 180, I'm going to get 112 degrees, or 114 degrees, excuse me. Do the math right in my head. 114 degrees. So then angle 4 has got to be 114, and angle 2 would have to be whatever adds up to 180 with it. Okay? So each time that we have one of these things in here, we're thinking about what that is. So I got a lot of people that said if this was 33 degrees, then angle 1 was 33 degrees. But you guys know that those two angles have to add up to 90. That's what that is right there, 90 degrees. So if this one up here is 33, then this one right here on that rectangle, this would have to be 57 degrees, because they have to add to 90 degrees. And that goes through some of those other ones on here. Here's the last thing I'm going to do, because I know that this is getting long. Is on like this picture right here. I'm not sure that we know the difference between these angle thingies, okay? So when I say angle JNM, I had people marking all kinds of different things on here. So J to N to M. So we start at J, we go to N, and then we go to M. So how big is angle JNM? That's 90 degrees. And then this says angle LMN is 25 degrees. So L to M to N, that one's 25 degrees, which makes that 25 degrees. And if this is 90 in here, if that's 25, then this is 65 degrees. This says LKM is 43, so I go L to K to M, right? That's L to K to M. Let me get another color here, purple. L to K to M, that's that opening right there. That opening is 43 degrees, okay? And if that's 43 degrees, then this one right here is 47 degrees, because those two things have to add up to 90. That's a 90 degree angle. If that's 43, then that's 43. And we kind of go through that way on the problem. Okay, sorry, my picture was off. Let me show you some other things that I got. I had people that told me that this angle right here, this length XY, was like 52. I'm going to say that, you know, if that's 97 and that's 47, I don't understand how we put 52. And I know that there's reasons going through our heads that do it, but we've got to think a little bit more and go, okay, well, what does it mean between those things? Okay. So it was true that 47 plus 97 divided by 2 equals XY. And sometimes people were just doing weird numbers with it. So I'm just asking you to check to see things make sense. Okay, well, if you are still here, first off, I want to know that I appreciate the fact that you took the time to watch the video. I only want you to have success. And I know, I've been doing this for 29 and a half years, that there are students that walk out of math class frustrated. I hate math, I hate Mr. Bell sometimes, just don't get it. I think there's little steps that we can take to make it better. And I think if maybe this hopefully was a help for some of the stuff with it so that things go a little bit better in the future. Again, always ask during the class, ask questions. And when we start to make the connections between the math, some of the things that are a little bit more frustrating might get a little bit easier for us to process. Again, hope this helps. Thanks for watching, and we'll talk to you later. Bye.